In this video, we'll be looking at how the Pascal's triangle forms the Sierpinski triangle. In case you haven't heard of the Sierpinski triangles yet, these are fascinating geometric structures named after the Polish mathematician Sierpinski. These are actually fractals, which means that they have self-similarity structures formed by repeatedly dividing a triangle into several other triangles. So let's start with an equilateral triangle. Divide it into 4 congruent equilateral triangles and color the middle one differently. We repeat this over and over and see the pattern unfold. As a fractal, the Sierpinski triangle exhibits self-similarity. This means that we can see the same pattern however long we zoom in the figure. For example, given the triangle shown, let's zoom in the bottom left. It looks the same as a big one. And then we zoom again on the bottom left, still looks the same. We can repeat the zooming in process infinitely many times and see the same pattern. What I've demonstrated is the most common way of generating the Sierpinski triangle. There are more ways, but what I'm quite surprised about is how, for some mathematical reason, the entries of the Pascal's triangle somehow forms this pattern. Now let's look at the first 8 rows of the Pascal's triangle. First, we just put these numbers into actual triangles and we'll color the spaces in between with white just to differentiate them from the background. Now I'd like you to examine the entries in each row. The number of odd and even terms vary in each row, and notice what happens when we color the even entries in white. The Pascal's triangle now looks a lot like a Sierpinski triangle. We can construct bigger Pascal's triangle and we'll see the same pattern. I will zoom in the table just so you'll see that I'm not making this up. The numbers shown are the last 3 digits of the binomial coefficients just for them to fit in the spaces. Note that indeed, all even numbers here are colored white and pink otherwise. It's just quite amusing to think how these seemingly unrelated things are related somehow. Math has these wonders, most of which are unknown to many. For the interested fellow, I'll leave the link for the proof why the Pascal's triangle behaves so in the description below. So that's it for this video, and hope you got amazed too. This ends the video, and thank you for watching. If you haven't subscribed yet, please consider doing so. And until the next one, see ya!